In this video, I'm going to show you how to solve 3 dilution calculation questions where the strength of the diluted portion of a solution is defined, but the strength of the concentrated stock solution used to prepare it must be determined, and we are starting right now. Hello, this is Dr. Damkwa. And if this is your first time here and you'd like to learn pharmaceutical calculations, tips, tricks, and strategies, then start by subscribing and clicking the bell so you don't miss anything. So let's get right to it. Here, the question is framed in such a way that you have some preamble, and the first thing we have is benzalkonium chloride solution. You have 240 milliliters of that, and you're supposed to make a solution such that if you take 10 milliliters and you dilute to a liter, you end up with a concentration of 1:5,000 in the solution. So it gives you the instructions: take 10 ml, dilute to a liter for external use. So the real question here is how many milliliters of a 17% stock solution of benzalkonium chloride should be used in preparing the prescription. So at first glance, it may be a little bit tricky how the question is framed, but I'm going to show you how to solve these kind of questions in 3 straightforward steps. Let's start off with a graphical representation of the information provided in the question. This would give us a good physical picture of what's happening in the question. That way, it will also help with our understanding of the various steps that we need to take in order to arrive at our solution. So we have a 240 milliliter benzalkonium chloride solution, and this solution actually is the stock solution. So this receptacle right here is representing the benzalkonium chloride solution, and the volume is actually 240 milliliters. Now our goal here is actually to determine how you're going to make this stock solution, but we know the information of our diluted solution. So the way we are going to make the diluted solution is we're going to take some volume from the stock solution, and this volume actually is 10 milliliters. And we are going to use this 10 milliliters to prepare a 1 liter solution. So the volume of this solution is actually 1 liter, or 1,000 milliliters, because 1,000 milliliters is equivalent to 1 liter. The other thing that we know about this solution is its concentration is equal to 1:5,000. So this is a ratio strength, which implies that you have 1 gram of benzalkonium chloride in every 5,000 milliliters of solution. So the important thing to note here also is that all of the solute in the 1:5,000 solution is coming from what is in the 10 ml volume that we took from the stock solution. So in this kind of question, it's more or less like you're working backwards to find out what the amount of solute is that you need to actually prepare the stock solution. But let's take a look at the steps that you want to follow to solve these type of questions. So the first step in our solution is to determine how much drag is in the 1 liter solution. And the way we do that is to make use of the ratio strength, which is 1:5,000. And the 1:5,000 implies that you have 1 gram of benzalkonium chloride in 5,000 milliliters of solution. But what we ended up preparing was a 1 liter solution, or 1,000 milliliter solution. So we need to determine how many grams of benzalkonium chloride will be present in the 1,000 milliliter solution. So we can go ahead and solve for x, which is our unknown. So x is going to be equal to 1 gram times 1,000 milliliters divided by 5,000 milliliters, and that is equal to 0.2 grams. Now our next step is to determine how much drug is in the 240 milliliter solution. Now it's important to recall that all of the 0.2 grams of benzalkonium chloride that is present in the 1 liter solution actually was contained in the 10 milliliter volume that was taken from the 240 milliliter stock solution. And so based on that understanding, we can set up a quick ratio, and we will state that the 0.2 grams is contained in the 10 milliliter solution. So how many grams of benzalkonium chloride is actually present in the 240 milliliter stock solution? So we can go ahead and solve for y, and y is going to be equal to 0.2 grams times 240 milliliters divided by 10 milliliters, and that is equal to 4.8 grams. So the next step is actually to determine the volume of the 17% stock solution of benzalkonium chloride that you need to use to prepare the 240 milliliter benzalkonium chloride solution. And so the way we'll do that is to make use of the percentage concentration of the stock solution of benzalkonium chloride. And so in the question it states that it is 17%. And so that implies that you have 17 grams of benzalkonium chloride in every 100 milliliter of solution. Now what we need is to take sufficient volume to provide 4.8 grams. So this 4.8 grams is the amount of drug that we calculated in step B, which is needed for the 240 milliliter solution. And so what we are interested in is the volume of the 17% stock solution that will give us 4.8 grams. So we can go ahead and solve for Z, which is our unknown, and Z is going to be equal to 4.8 grams times 100 milliliters divided by 17 grams, and that is equal to 28.24 milliliters. Let's take a look at another question. This question says, how many milliliters of water should be added to 100 milliliters of a 1:125 weight by volume solution to make a solution such that 25 milliliters diluted to 100 milliliters will yield a 1:4,000 dilution? So let's start off with a quick schematic. So you have some stock solution, which you're actually going to prepare by adding some more water to the 100 milliliters of 1:125 weight by volume solution. But once you've done that, you're actually going to take out 25 milliliters and make a more diluted preparation, which is 100 milliliters. So the volume here is 100 milliliters, and the concentration is 1:4,000. So let's amplify the schematic by summarizing what we know about this particular scenario. So we know the final concentration, which is 1:4,000. We know the final volume, which is 100 milliliters. And what we also know is that all of the solute that is present in the 100 milliliter solution having the concentration of 1:4,000, all of that solute came from the 25 milliliters that we took from the original mixture. Now, what we know is that in the original mixture, you had 100 milliliters of a 1:125 weight by volume solution, but we need to dilute it before we take out the 25 milliliters. So we don't know the volume of water that needs to be added to dilute it down, and that is what we need to determine. But the way you go through this problem is to go through 3 major steps. And the first step here is to determine how much solute or drag is present in the 100 milliliter solution having the concentration of 1:4,000. Now, since the concentration is 1:4,000, it implies that you have 1 gram of solute in every 4,000 milliliters. But we prepared a 100 milliliter solution, so we want to determine how many grams do we need to make the 100 milliliter solution. So we can go ahead and solve for x, which is our unknown here, and x is going to be equal to 1 gram times 100 milliliters divided by 4,000 milliliters, and that is equal to 0.025 grams. So now the next step is to determine how much solute is present in the 100 milliliters of the 1:125 weight by volume solution. So the way we'll do that is to make use of the ratio strength, which is 1:125, and that implies that you have 1 gram of solute in every 125 milliliters of solution. But we are actually interested in determining how many grams is actually present in the 100 milliliter solution that we started off with. So we can go ahead and solve for our unknown, which is y, and y is going to be equal to 1 gram times 100 milliliters divided by 125 milliliters, and that is equal to 0.8 grams. So for the next step, we want to determine the volume of water that needs to be added to the 100 milliliters of the 1:125 weight by volume solution. And so the way we will approach this is to take the 0.025 grams that we determined from the first step, and this 0.025 grams was actually present in the 25 milliliter volume that we took, and we actually diluted to 100 milliliters to get a 1:4,000 dilution. So we'll set up this ratio, and now we'll transform this into a proportion to determine that if we actually have 0.8 grams, which is the value we determined in step B, then what would be the total volume of that mixture? So this ZML represents the total volume of the original mixture from which we took out the 25 milliliters. So we can go ahead and solve for Z, and Z is going to be equal to 0.8 grams times 25 milliliters divided by 0.025 milliliters, and that gives us 800 milliliters. But notice that the 800 milliliters that we just determined is the total volume of the original mixture from which we took the 25 milliliters. So to actually determine the volume of water that needs to be added, we need to do another step, and that would imply that we need to take the 800 milliliters and from that subtract the 100 milliliters that was originally present. So 800 milliliters minus 100 milliliters, and that will give us 700 milliliters. So the volume of water that needs to be added is 700 milliliters. Let's take a look at another question. Here you have a prescription which says you have zephyran chloride solution 17% weight by volume, and you're going to add sufficient purified water to make 480 milliliters. Now you're instructed to take 1 tablespoon, dilute to 1 gallon with water to make a 1:10,000 dilution. And the question is actually saying how many milliliters of zephyran chloride solution should be used in preparing the prescription. So let's start off with a schematic. And what we have is our 480 milliliter stock solution. So volume equals 480 milliliters. And then from that, we are going to take out a tablespoon. So 1 tablespoon is actually equivalent to 15 milliliters. So we're taking out this volume and we are going to use that to prepare a 1 gallon dilution. So here the volume is actually 1 gallon, and 1 gallon is 3,785 milliliters, and the concentration is actually 1:10,000. So here the first thing we want to do is determine how much zephyran chloride is actually present in the 1 gallon solution. And the way we will do that is to make use of the ratio strength of the solution, which is 1:10,000. And so that implies that you have 1 gram of zephyran chloride in 10,000 milliliters of solution. But our goal is to prepare a 3785 milliliter solution or 1 gallon solution. So we want to determine how many grams is actually needed to achieve that. So in the denominator here will be 3785 milliliters representing the 1 gallon. So we can go ahead and solve for our unknown, which is x. And so x equals 1 gram times 3785 milliliters divided by 10,000 milliliters. So x is going to be equal to 0.3785 grams. So here the next step is to actually determine how much zephyran chloride is present in the 480 milliliter solution. Now, you want to recall that all of the solute that is in the 1 gallon solution or the 3785 milliliter solution, all of that zephyran chloride solute is coming from the 15 ml volume that was taken from the 480 milliliter solution. So that is significant because in order to determine how much zephyran chloride is present in the 480 milliliter solution, what we want to do is to take the 0.3785 grams and set up a ratio, because all of this quantity is present in the 15 milliliter volume that we took from the 480 milliliter solution. And so we can set up a proportion to determine how many grams is actually present in the 480 milliliter solution. So we can go ahead and solve for our unknown, which is y, and the y equals 0.3785 grams times 480 milliliters divided by 15 milliliters, and that is going to be equal to 12.1 grams. And so the next step will be to determine the volume of the 17% zephyrine chloride stock solution that you actually need to use to prepare the 480 milliliter solution. And so the way we will do that is to make use of the percentage concentration. So we take the 17%, which implies that we have 17 grams of zephyrine chloride in every 100 milliliter of solution, and we set up a proportion to determine what the volume would be if you actually had 12.1 grams. So we are interested in this volume. Let's call that Z ml. So we can then go ahead and solve for our unknown, which is Z, and that's going to be equal to 12.1 grams times 100 milliliters divided by 17 grams, and that is equal to 71.18 grams, or approximately 71.2 grams. So I hope you found this video tutorial useful. If you did, be sure to like it and share it. And if you have any questions, leave them in the comments and I'll get to them as soon as I see them. If you'd like to learn more pharmaceutical calculations, tips, tricks, and strategies, then start by subscribing and clicking the bell so you don't miss anything. Thank you so much for watching, and I will see you in the next video.